Hello everybody, so today I will talk about the system design of WhatsApp. So as you can see, I'm in the library now and the librarian allowed me to take this video here, so I'm shooting this. But yeah, maybe it's a bit noisy in the background, but please bear with me, bear with it. So design WhatsApp. So WhatsApp is the messaging chatting app. So as a function requirement, users should be able to send messages in the chat. But I think for the first place, we need the chat space. So user can start the chat with multiple people, multiple friends maybe. So in this video, I will talk about the group with multiple people rather than one-to-one. But I'm pretty sure one-on-one chat is a kind of specific version of the group chat. Okay, and user can receive the messages in the chat room. And when I think of the chatting app, something I have to think is real-timeness. So obviously users should be able to receive the messages in real time, less than 1 second. Yeah, but what if the user is not online? In that case, the user should be able to fetch the past messages while he was offline. So I will add it to the function requirement too. Okay, so this is the function requirement, I think. Let me check. User can start the chat with multiple friends, and user can send messages. User can receive the messages in real time while he's online, and user should be able to receive the messages while he's online. No, while he was offline, while he was away from the app. Okay, looks good. Now I'm checking my note. I'd like to make it more specific. So user can send receive messages with media. And also I will add one more kind of specification. So while they're not online for 30 days. Okay, so now these are the function requirements finalized. Okay, so now I do the non-function requirement. So I firstly go with the cap theorem. So in cap theorem, I can guarantee up to 2 of strong consistency, availability, and partition tolerance. And because we are designing the distributed system, partition tolerance is a must. So now we have to choose from strong consistency versus availability. So when I think of this, trade-off discussion, I can rephrase this as if the user should be able to receive the latest message, latest write from the other user every time. And if it is not possible, but if we'd like to achieve that, the system may not be available all the time. So this is when we choose the strong consistency. But when we choose availability, it means that the latest message is not available maybe, but the system keeps working and user can get a bit outdated message. So that's the comparison. So when I think of this, I choose availability. So this means that maybe user cannot send the latest message, but system keeps working and user can always get the a bit older message, even if it is not the latest. Okay, now the second one is low latency. I will set the number 500 millisecond here. So this is for, let's say, starting the chat, creating the chat room API, also for the sending the message, and also for receiving the message. So there should be some delay, like, or I should say, I said real time, the word real time here, but this is up to 500 millisecond, I mean. And the first one, yeah, this receiving the past messages, this should be done within 500 milliseconds. So when user opens the chat room after he was offline, the messages which were sent to him should appear within 500 milliseconds. Okay, and I will talk about the durability. So the messages are stored and it will never be lost before it's sent to the user. This is definitely important in the chatting system. And also we'd like to guarantee the security. So the message should not be leaked. It's a very, critical issue if the message is leaked, because it's completely the privacy, data of the privacy. Okay. So now I will check my node quickly. So, okay, I will add the scalability and also guarantee the delivery of messages. Okay, let me add it instead of durability. So what was it? So okay, so I will add this one because they're very important. And for security, I will be more specific. So messages are stored securely, and messages are deleted once delivered from our system. So we don't want to store the messages unnecessarily. And I will add the scalability here. Okay, so this is a non-functional requirement of this system. Good. Okay, so now I will talk about the core entities. So core entities are a kind of the table names of the system we will have in the database. So I will clarify which entities are necessary here before going into the high-level design. So firstly, we need user and chat room, and we need the message, and we need media, and we need media metadata. So what I mean here is, let's say user sends a message. Let me say image to be clear. So let's say user sends the image with the message. In that case, what happens is that the image has a kind of metadata, like the file size, file extension, when the message was sent, and who sent that image in which message. So those are the metadata of the image, which I will define as the separate entity from the image. Okay, and now I will do the API design. So I will see one by one. Firstly, user should be able to create a chat room. So we need to create chat room API, and also I will just list the API names here first. So user can start a chat with multiple friends, and user can send messages with media. So user should be able to send message, and user should receive the messages in real time. So receive message, and we need receive, which is the real time messages, and receive past messages. So now I'd like to talk about two things before gonna be more specific about each API. There are two problems I'd like to discuss. One is the media sending. The other is real-time message fetching. So for the first one, sending the image, I will definitely store the images in the S3, which is the blob storage. We can send the images in the database, but database like PostgreSQL is not created for that purpose. Even it is possible to send them, it takes much more money, and we cannot use any PostgreSQL benefit from that, like B+3. And S3 blob storage is created for that purpose. So we will store the blob images in S3. And when I think of that, I have two options. Number one, when user sends a message, client sends a message to our backend server, and our backend server stores the image in S3. So there are two hops here: user to our server, and then our server to S3. But there is another option here. The second option is user sends the message to our server, and then we return the S3 URL for the user to upload the image. And then in the second hop, user sends the image with that URL. So that's the second option. So, and comparing this, I will go with the second one, S3 pre-signed URL. This is because if our system receives a message, media, it can overload our server because images can be quite big, like maybe 1 megabyte, 2 megabyte. So I choose the design that user sends the images, media, to the S3 directory. So this means that we need the API to send versus a save media, as a separate API. And same for receiving the messages. In either way, receiving real-time messages or receiving past messages in bulk, we need the API to download media from the client. Okay, now I will talk about the second point, real-time message fetching. So when it comes to the real-time fetching, there are three options, I think. Number one is short polling. The second option is SSE, server sent event, or we can use the kind of WebSocket. Firstly, I will compare these options quickly. So short polling, this is based on HTTP, and client tries to fetch the message again and again. So some client makes a request to our server side if there is a new message or not. And if there is, we return that message. So the client keeps doing again and again. And SSE, so this is based on HTTP, but okay, so I changed my place. So I talked about short polling, and now I will talk about SSE. SSE is server-sent event. So this is based on HTTP request, but this is unidirectional. So once the client sends a request to the server, the connection is kept alive, and messages from server to client is delivered through that connection. And so that's SSE. And for the inner case, for sending messages, we have to use another API to send the message. So this is for typically for unidirectional server to client message style. Okay, so this is SSE for WebSocket. Actually, this is not based on HTTP. For layer 4, this uses TCP, which is same as HTTP, but layer 7 is different. And for WebSocket, we can use it for bidirectional connection. So with the WebSocket connection kept alive, client can send messages as many as they want and whenever they want. And client can send messages as many messages as it wants, and whenever it wants. So this is a WebSocket. That being said, I will choose WebSocket in this question, in this design. So the problem with short polling is this can overload the server resource, because in our case, we have to fetch the message every 500 milliseconds. This means that every client has to do short polling every 500 milliseconds. So this is very heavy for servers. So I don't go with this. And for SSE, because this is the bidirectional, I will go with WebSocket. Yeah, we need API to send client to server. Yeah, so rather than that, I will choose WebSocket. Yeah, of course, there is a kind of shortage in WebSocket. The biggest problem is the WebSocket, we need the infrastructure for WebSocket connection. Yeah, but I will accept that shortage in our design and go with the WebSocket. So that being said, because we use the WebSocket, wait a minute. Because we use the WebSocket, now I have to adjust the API design to use the WebSocket. So receive real-time message and send message, these are done in the same WebSocket connection. So I would say send receive message. And this should be WebSocket. And receive past messages, I will do this one with still HTTP. Yeah, so that I can separate the API to, for real-time messages and bulk past message fetching. So to be more, for the detail, for create chat room, we use host and we need the header, which includes session token. Now our server side can know which user is making the request from this session, and we need the user IDs used for, who are invited to the chat room. Then we return 204 or maybe 200 with chat ID. and now client can describe the chat room in the front end. For send and receive message WebSocket, I will use WebSocket and messages, and we need the header still to know which user is making the request. So this is possible because WebSocket is a kind of how should I say, wait a minute, so let me quickly check. Okay, so I do search something here. So how to do OSINT WebSocket connection. So we cannot use HTTP headers. So it says ticket-based authentication. So it seems like this is, yeah. First we make the request with HTTP and gets a ticket and use that ticket. And this is used as the kind of session token for WebSocket connection. And maybe we can use post handshake message authentication. And we can use HTTP cookies. Server should private domain. The browser will automatically forward cookies during the initial HTTP. The browser will automatically forward cookies during the initial HTTP upgrade request. In this site. Sorry, my camera was off, but now I will do the high-level design. So there is a user, or I should say front-end app, and I will start with the create chat room. So I do the microservice architecture here. Yeah, there are some reasons. Firstly, I think there are some justifications. We can use the API gateway. Firstly, because as the domain gets complex and more complex, we'd like to separate the service and the team owner so that the responsibility for each service is clear, and we can separate the domain to services. And also I can say, because yeah, we'd like to make the each feature work without the, I want each feature to work separately, even if there is some problem in other features. For example, even if the user cannot create this new chat room, he should be able to receive past messages or real-time messages. So for that, I will separate the services so that the kind of fault and disaster problem in specific service doesn't affect others. So here I will use the chat room service. So when user makes the request to create a new chat, the request is routed into the chat room service from API gateway. So this API gateway does routing, authentication, maybe rate limiting. And now chat room service saves. So this is a very basic CRUD service. So this saves the chat room data into the database. So I think I can use the PostgreSQL here. We don't have specific requirement for database yet, but typically we would try to fetch users with associated with the chat room. So probably we use the join queries so often for this purpose. So I think PostgreSQL is good for now, but I will change the database if necessary later. And because, as I said, we want to choose the chat room data and also user data here, so we call it primary DB. So we store user data and chat room data. And of course, we need the user chat room relationship. So in this way, this is a relational kind of relation table. So this is foreign key, and this is foreign key too. To be clear, why I have to need this, because if I try to include that relationship in the chat room table, chat room has kind of user IDs column, and the query becomes very complex. So that's why I'd like to use the user chat room relation table here. Okay, so now this service creates the record in PostgreSQL. Good. Okay, so now we'll talk about the second API, WebSocket. So as I said, I will need a specific service for this. So for this one, we need the user to send the message. And because this is WebSocket, this connection has to be kept alive. Okay. And I will think there is only one server for now. I will talk about the scalability later. And the thing is, user sends the message and it from this WebSocket, and this is sent to the stored in the messages table. So this should have messages. And user ID, chat ID. And okay, also we need the media ID. So what happens is that now message is sent, and if he try to send the media with that, this also hit S3. So this real-time chat service hit S3 to issue pre-signed URL. Then this pre-signed URL is returned to the user. Also the message too. Okay, sorry, I will talk about the deliver message later. But here I was talking about send message command, and message is stored in the DB, and that's it. But if he'd like to send some image, this real-time chat service also hit S3 to issue the pre-signed URL and returns it to the user with notify S3 URL command. So this is returned to the user, and the front-end app renders the message, and that's it. And now I will talk about deliver message command. So this is a kind of tricky. How chat service can know which WebSocket connection the message should be delivered. So as I said, I would think that the service is still small, and this is handleable by only one chat server. In that case, I can say chat this service stores chat ID to WebSocket connections list. So this is a mapping. So with this, when the message arrives real-time chat service, this service knows which WebSocket the message should be delivered, and to those WebSocket, this sends deliver message command message through WebSocket, and now user can receive the message. Good. Now next, download media. So this is quite simple. Sorry, I forgot to talk about uploading media too. So upload image here, and when the message is uploaded, this is good, but also we'd like to know the messages we'd like to know if the media was uploaded yet or not. So as I said, we need media metadata. So image metadata. So this has user ID and chat ID, maybe message ID. Actually, this is redundant because as long as we know the message ID, we can know which user sent the image in which chat. Okay, so this is the table names, and we can use CDC to upload media upload status. For CDC, we can use S3 notification. The notification triggers AWS Lambda, and that Lambda can update media upload status column. So this is upload image. And for download image, quite similar. So when the message is delivered with deliver message command, this should include the pre-signed URL. Optionally, and the client side can download the image from S3 directory with pre-signed URL. Okay, so last one, receive past messages. I will make another service named past chat service. So client can hit this API and get all the past messages it hasn't been delivered. And this hit message DB to get the past messages and return it to the user. And optionally, if there is an image included in the message, the client should fetch the image from S3 in the same way. Okay, so this is it. Good. So I kind of hand-waved the process, how the server side can know if the message was delivered or not for this past chat service, but I will talk about it later soon. Okay, and I forgot to talk about this message DB. So we forgot to talk which DB I should use. I will go with DynamoDB here. The reason why I'd like to use it is because we can use TTL. So with this TTL, messages sent out. So with this, I can set this should be sent out plus 1 month. So with this, the message is sent 1 month later. So actually this TTL is not exactly the time the record to be deleted. So there may be some delay, like a few hours until this message is deleted. But still we can omit the cost to kind of there is a message, updated message with cron job or something. So I will use TTL of DynamoDB here. Okay. Now I will talk about the non-functional requirements. Low latency guarantees the delivery of messages. Okay, I will go with this. And I think this one and this one, security, messages are deleted once delivered. They can be resolved in a same way. The thing is, we have to keep track which messages are sent. So instead of this, I will use delivery tape record here. Wait a minute. So here, for each message, I'd like to know which user should receive this message and send status. So the thing is, when the message is created, message delivery box is kind of created too. And when the message is sent user, server side update this sent boolean to true. Okay. And if all the message delivery in the first message is true, now I can send the message here. But because we have TTL, this is a kind of optional. We really have to delete the message when all the user receives. I should create a cron job to delete message, but if it is not so strict, we don't need it. Okay, so this is how I can guarantee the delivery of the message. Okay, so the thing is, once the message is sent to the user send acknowledge message. So this should include the message ID. Sorry, this should be text. And this should have text obviously, because this is a message. So once user acknowledges the message here, this where chat service should delete updates the message delivery flag. So this is something happens here. I'd like to write it here. So, okay, so first, send message command. Then secondary, notify S3 URL. Sorry. I mean here, save messages. Then here, return S3 URL. Then this uploads the message. Then once this is done, this S3 notification occurs. And then wait a minute. I will just include it from these numbers for clarity, for simplicity. So this is saved, and then the message is sent to the user. Then client acknowledge the message. Then this real-time updates the change flag, and now message delivery sent is flipped. This flag is flipped. Yeah, that's it. Okay, so this is all about the sending and receiving message flow. And one more thing, when we save, I should say create message and delivery records. So when the message is sent to the user, when the message is sent from the client, this real-time chat service creates the message record and also message delivery record for all the users who were in the same chat room. We need chat room here. And those are done in the same transaction. So if the message creation fails, message delivery should not be created. So we'd like to do that once that was admitted here. In that way, user can retry sending the message if something fails, and this doesn't mess up the database table records. Okay, so that about the message delivery. And I will quickly talk about the security. So messages are saved in the S3. So what I'm talking here is S3 security at rest. So yeah, we can use the encryption in S3. So I will enable encryption for the images in in S3. And obviously I have to talk about how I can encrypt the messages in DynamoDB. So let me quickly check. Okay, so this is it. The quite similar way we can use server-side encryption, SSE. So I do encryption for this too. So in this way, message text and message images are encrypted at rest in the server side, so they are secure. Okay, so I will add something about the DynamoDB. So justification to use DynamoDB. Actually, this works with, PostgreSQL, but actually I don't have a strong reason to choose DynamoDB here. PostgreSQL completely works, but let's say the message is more and more, we have to use a sharding, and for the sharding, DynamoDB is much easier because all we have to do is set the partition key, and internally in DynamoDB, the server data is, partitioned based on the kind of consistent hashing algorithm. But for PostgreSQL, the application side has to manage the sharding, so we have to write the kind of logic to do the sharding in the application code. That's a bit annoying. So if the data is kind of more becomes, data will increase and we'd like to do the sharding, I think DynamoDB is good in that perspective. But again, we don't have strong reason to use DynamoDB here. But one more thing, DynamoDB has a kind of limitation on the transaction of records. So I think it was 100. So which means that when past chat service create one message record, and it can create up to 99 message delivery record, which means that the number of users in the same chat room is limited to 99. This is a product decision if we accept this or not. But yeah, but for now, I think 99 is many enough. But if we want more users, maybe we should use PostgreSQL instead of DynamoDB. Okay, and now I will talk about which should be the foreign key, which should be the partition key here. So for message delivery, I think this is quite easy. This should be partition key, should be user ID, and salt key should be message ID. And for message ID, we use UUID3 because UUID3 never collides, and this is kind of sorted by the timestamp this ID was created. So with this, instead of timestamp, we can create message ID. Yeah. The good thing is in this way, messages are sent according to the message it was created. Okay. And send that. Wait a minute. So for messages table, I will think of the access pattern. So this message itself. Oh, wait. The thing is, when I think of the message delivery, I also want the text here, kind of redundant here. But this is, I think, very good approach here because message in a specification is not updated. So when the message is sent, it doesn't have to take a look at messages table. Text is here, and maybe standard ID is here. So we can use this redundancy here in message delivery. So in that way, we can reduce the access to the, we don't have to access the messages table when we send the message. That being said, this message master data, I would say master data compared with message delivery doesn't have to be accessed. It's kind of master data. So yeah. So actually we don't have to be super strict about thinking of the foreign key, partition key discussion. So yeah, I will use partition key as a message ID here. Okay, good. Now I talked about the non-functional requirement aside from scalability. I will talk about the scalability discussion in the second video. So that being said, I finished my today's practice. Thank you so much for listening with some noise. So bye.